Good day. Let's dive into binomial expansion by doing Pascal's triangle. How can you expand a binomial expansion by Pascal's method? So this is what we are going to look at. Okay. Pascal's triangle. So there are certain instances whereby you have, let's say, expand a plus b to the power 20. It won't be possible for you to expand this by starting to say maybe a plus b times again a plus b times a plus b times a plus b. You waste a lot of time. At the end of the day, you might get confused in the expansion and things will go complicated. So there's this method on binomial expansion which is called Pascal's triangle, which can help you to expand a certain expansion or binomial expansion rather in a shortest period of time without any mistake or any errors along the expansion. So now let's look at how this Pascal's triangle is formed. So we'll start by forming the Pascal's triangle. You don't need to master it, so you just come up with it. So Pascal's triangle, you just need to know how to form it, not even how to master it. You won't be able to master it for all the terms, so the best way is to know how to derive it. So let's start with 1. So we have 1 there. In fact, let me even rub this. Okay, let's start with 1. So when you have 1, write 1 also at the edges. So 1, then you write 1 like that. Then you always start with 1. The next thing you're going to do, you add 1 plus 1, so you get 2. Then you end with 1 again. You always start with 1, you add 1 plus 2, that is 3. Again 1 plus 2, that is 3. Then you end with 1. You start with 1 again, then 1 plus 3, that is a 4. Then you add the 2 numbers on the middle, that is 3 plus 3, that is 6. Then again you come to 3 plus 1, that is 4. Then you end with 1. Once you reach 1, don't proceed. It is the end point there. So again you start with 1. 1 plus 4, that is 5. 4 plus 6, that is 10. 4 plus 6 again, 6 plus 4, that is 10 again. Then 4 plus 1, that is 5. Then after 5 you end 1. Okay, so this one is for expansion of a. This one is just for the expansion, that is for the expansion of a to the power 0. This one is just for the expansion of a plus b to the power 1. Then this one is for expansion, the one we have 1, 2 and 1 is for expansion of a plus b rather raised to the power 2. So this binomial expansion by using Pascal's triangle will help you find the coefficient in an easy way. So this one, which has 1, 3, 3, is for expansion of a plus b raised to the power 3. Then this one, which has 1, 4, 6, 4, 1, is for expansion of a plus b raised to the power 4. Then the other one, which has 1 plus 5 plus, 1, 5, 10, 10, 5, 1, is for expansion of 1 plus 1, a plus b rather, raised to the power 5. Then let's proceed with the Pascal's triangle. so that you know how other values come about. So let's continue. So 1, we go to we start with 1 again, the same way we're doing it. Then what is 5 plus 10? That is 15. 10 plus 10, that is 20. In fact, we've missed something here. Okay, so we start with 1. Then we add 1 plus 5, that is 6. Then 5 plus 10, that is 15. Then 10 plus 10, that is 20. Then again you come back to 10 plus 5, that is 15. Then you say 5 plus 1, that is a 6. Then you end with 1. So this is for an instance whereby you've been taught to expand a plus b, then raise to the power 6. Let's continue with this. So we start with 1 again. 1 plus 1, that is a 7. Then we come to 6 plus 15, that should be a 21. 15 plus 20, that should be a 35. Again 20 plus 15, that should be a 35. Then 15 plus 6, that should be a 21. Then 6 plus 1, that should be a 7. Then you end with 1. This is an instance whereby you've been given a plus b, then raised to the power 7. Then let's end maybe up to 8. So we come to 8. So 1 plus 7, that is 8. 7 plus 21, that should be a 28. 21 plus 35, okay, that is 6, that is 5, okay, that is 56. 35 plus 35, that is a 70. 35 plus 21, that is a 56. 21 plus 7, that should give a 28. Then 7 plus 1, that should give 8. Then we end with 1. This is whereby you've been given to expand a plus b, then raised to the power 8. Now let's look at how you can apply this Pascal's triangle in evaluating binomial expansion. We'll say maybe you've been given expand x plus 2 raised to the power 4. How can you expand this? It is very easy if you know the Pascal's triangle, but if you don't know it, you waste a lot of time and maybe you might not even get it right. So let's apply. The first thing, we need to know the coefficients for expansion up to 4. The coefficient, we said they are 1. So for up to 4, they are 1, 4, 6, 4, 1. Those are the coefficients. So you need to get from the Pascal's triangle, which we've just looked at. Then you start 1. So you just say 1 is just 1 multiplied by x is just x. So you start with the x to the power 4. Then x will be decreasing. So we are saying this x is our a, then 2 is our b. So what happens with binomial expansion is that as one value is increasing, the other one is decreasing. So in this case, the first value, which is x, will be decreasing in power, while the other one, which is b, will be increasing in power. So this is what happens. So we'll start with x plus 4, then we'll say plus, what is the coefficient there? It is 4. So you write 4. Then x, you write x. So x is going to decrease from 4 to 3. Then what will happen to b? B is going to increase from 0. Of course, we never had 2 to the power 2 to the power 0 in the first expansion, because we know that 2 to the power 0, any number is to the power 0 is just 1. So no wonder we ignored it. So this 2 will increase by 1. Then plus, we come to 6. You see, right? So 6, then x will decrease further from 3. The power will decrease to 2. Then this 2 will gain 1. So it will be from 1 to 2 now. Then we come to plus 4. Plus 4. Again, the x will decrease in power from 2 to 1. Then the b we increase in power from 3 to 2. Then plus what you end with is just b. So don't even start saying x now has decreased to 0. That is just wasting time. So you just say 2, then to the power the maximum power now. The maximum power is 4. So it has increased from now 3. In fact, that was supposed to be 3 there. Then 2 to the power 4. So that is what you need to do. So you can expand it now. X to the power 4 plus this is 2 times 4, that is 8, so it will be 8 x to the power 3, then plus 2 to the power 4, that is 6 times 2 to the power 4, that is 4 rather, then 4 times 6, that is 24. So we're going to say 24 x to the power 2, then plus 2 to the power 3, that is 16 times 2 to the power 3, that is 8, sorry, then 8 times 4, that is should give 32, then x to the power 1, just 1 there, then 2 to the power 4, that is 16. So this is how you get to expand using binomial expansion. Let's look at another interesting question whereby maybe you say expand x minus 1 over 3, then raised to the power, not even 1 over 3. Let me get something. Okay, yeah, x to the power 1 over, yes, let's maintain 1 over 3. 1 over 3, then to the power 5. How can you expand this? So the first thing, know the coefficients. So the coefficient for 5, from our previous one, we said it is 1, 5, 10, 10, 5, 1. That is the coefficients we got from the binomial expansion, right? So we'll start. So x to the power 5, of course, then plus x now will decrease. In fact, we put the coefficients first. That is 5. We get the coefficient 5 there. We've already taken 1, so 1 times anything is just the same thing. So it will be 5, then x will decrease to 4, then our b will increase by 1. But take note that b is negative 1 over 3. Then we'll increase by 1, then plus we go to 10, the coefficient. Then what is our 10? That is our x there. X will decrease from, that is 4 to 3 now. Then our b negative 1 over 3. Then it will increase from 1 to 2. Then plus we get 10 again. X will decrease to 2 from 3. Then our b will gain 1 from 2 to 3 now. Okay, this is a binomial expansion. Then plus I've come this side due to lack of space, so plus we take the coefficient which is 5, right? 5, then x will decrease from 2 to 1, so even if I don't write 1, it's okay. Then our b from negative 1 over 3, the power was 3 there, it will increase to 4. Then plus the next thing, just write negative 1 over 3 raised to the power 5, the maximum power. So what are you able to observe here? As x is decreasing in power, the other variable, which is b, as a is decreasing in power, b is increasing in power. So what you end with, the maximum at a should be the maximum at b. So the power at a, which is 5, should end with b, which is 5. So that is how you get to expand. So the next thing here is just to use your algebra in order to simplify this. You just get to simplify, right? So it will be x to the power 5, then you have negative 1 over 3. Negative 1 over 3 times 5, that is just negative 5 over 3. then x to the power 4. Then you come to this one. This one you have 1 over 3, negative 1 over 3 raised to the power 2. That is just 1 over 9, right? 3 to the power 2, that is 9. So 1 over 9 times 10, that should give a positive 10 over 9. 10 over 9, then x to the power 2. It's x to the power 3, not 2. Okay, it says 3 there. Then we come to this one, negative 1 over 3 raised to the power 3, that is negative 1 over 27 times 10, so that is negative 27, negative 10 rather, negative 10 over 27, then x to the power 3. Okay, let me get rid of this, so that is 27 there. Okay, then what I've remained with, then I'll say plus, this is negative 1, this is to the power 4, it is to the power 4. So we're going to say negative 1 over 3 to the power 4. 3 to the power 4, that should give, and that is 81. So it will be negative 1 to the power 4 also is positive. So you just say 5 multiplied by 1 over 81. So that is just 81 over 5, then x, just x to the power 1. So even if you don't write the 1, it's okay. Then negative 1 over 3 to the power 5. For this one, you can just say 3 to the power 4 is 81. Then you say what is 81 multiplied by 3 again. So that is 1. That is 8 multiplied by 3. That should give, is it 24? Yes, 24. So it will be, and negative 1 raised to the power 5 is a negative value. So you're going to say 1 over 2 to the power 4. So it will be negative 241. Okay, so that is the value which you tends to get. So this is how you can expand, and in an exam this question is given 4 marks. Yeah, we are done with Pascal's triangle. Thank you for watching.